Hi everybody, thanks for tuning in to this latest example of how to parameterize the SIMOCODE station. So in this example, I want to show you how to use the function in machine monitoring where it allows you to observe the current. So I'm assuming that you've already got the base there of the program, whether it be programming a DOL or a reverser. If you haven't, please refer back to one of my previous examples. So what we're going to do now is we're going to jump into the control station, the SIMOCODE Pro VPN, drop that submenu down and go into parameters. So as you can see here, there's a number of different parameters which you can set. We want machine monitoring. You can drop that submenu down to current limits, and once you're in the current limits function, we're now ready to start having a look at the various different options. So these options are particularly useful. So you have an upper limit and a lower limit, and you can have a trip, a warning on both the upper and the lower limit, and you can even set the hysteresis for the current limits. So the idea is the hysteresis control allows the inductor current to vary between two extreme points, and that's the percentage of allowance on that deviance. So in the higher upper limit current. So this could be particularly useful, say for example, if you've got a conveyor belt application and something's been jammed in the conveyor and it starts to block the conveyor. This higher limit will prevent the motor from overheating and preventing damage to the motor windings. You can set a slight increase warning level to suggest to an engineer when the motor might be operating out of its normal operating conditions. That could perhaps indicate potential bearing wear. And then on this lower limit, if you have, say, for example, a conveyor application, you could perhaps set a lower limit which would indicate that there's no load on the conveyor on the warning level, and if there's no load whatsoever which is being shown, it might indicate that the conveyor belt has actually snapped. So these are great indicators of how you can monitor the current and prevent damage and start predicting maintenance by using the SIMOCODE station. So what we can do here is in the higher current limit, we can say, okay, we want a trip level at 148% of the current. How do we want to react to that? Well, we want it to trip. Do we want to delay? So the delays are good if you have a slight fluctuation in the current. You might not want it to trip out straight away because then you could get involved in nuisance tripping. So if you put a delay on that, it'll eradicate that potential issue if you do have slight current rises intermittently. In the warning level, we'll set that at 120%. How do we want it to react to that? We'd like it to warn us. Similarly, in the lower limit, it's exactly the same. How do we want it to respond at the lowest level? We want it to trip at 72%. Similarly, here we also have a warning sign. So at the warning level, we'll set that to 88%. And how do we want it to react? Again, we'll have it set to warn. So now we've set those functions again. You can also delay those two functions if you wish. Now we can test that out by simulating this in the commissioning parameters. So first we'll download that into the SIMOCODE station. So now we can go into the commissioning side of things. If we click on the commissioning tab and then press go online here. Once this blue bar has turned orange, we know that the device will have entered the online parameter set. So now the bar's gone orange. We can now start to have a look at the demonstration rig. So my unit, my laptop, is connected directly up to a SIMOCODE station with this program built into it. We're just going to view it through the diagnostics window. So there's a couple of tabs in here which can be of use. So we've got the measured values tab to see where the percentage of the current's at, but also to see here where the warnings and the faults are when we trip. So if we have a look and we initiate a start of the motor, so it's coming in at 103%. So if we go into if we turn the current up to say 120, that should trigger the warning on the upper limit. Let's take a look at that now. As you can see, the warning level has been initiated. If we go and turn that back down again, let's breach the warning limit on the lower threshold to see whether that's actually worked. As you can see, the lower limit has now been breached. And then the last thing to test would be whether the actual current threshold has worked as well. So we'll test that on the lower limit. So we'll turn the current right down and see whether the unit actually trips out. As you can see, it reached the threshold that we'd set to trip, and it's just automatically cut the SIMOCODE station out. So as you can see, the SIMOCODE function for the current is quite thorough. It's a really great and useful feature to have if you're looking at observing how the current reacts under certain conditions, and it's a great tool to use to predict maintenance. So I hope you found the video useful, and please stay tuned for more to come. Thank you.